We're going to use the integral test to show that the series from n equals 1 to infinity of n squared e to the negative n cubed converges. So when we start out by taking the divergence test, as we always do, when we look at the limit as n goes to infinity of n squared e to the negative n cubed, this is the limit as x goes to infinity of x squared over e to the x cubed. And we know that since we have a polynomial over an exponential, that this limit is definitely going to be equal to 0, which means that we don't get any information out of the divergence test. Right, so we see that this is the limit as x goes to infinity of 2 over 3x e to the x cubed, or 0. So there's no new information. When we take a look at the function that defines the terms, f of x here is equal to x squared e to the negative x cubed. We look at that and we say, I bet we can integrate it. X squared e to the negative x cubed. We can integrate this with a u sub. U here is equal to x cubed du is 3x squared dx. So we end up with 1/3 e to the negative u du. And our integral is going to be negative 1/3 e to the negative u, or negative 1 over 3 e to the x cubed. All right, so this is something we can definitely integrate. All right, the other things that we need to check are, is it positive? And just looking at it, we can see as long as our x values are greater than 0, then it is going to be positive. Is it continuous? Absolutely. It's a product of continuous functions. And then finally, is it decreasing? And here I think we should check the derivative of this function. So if the derivative is negative, then that tells us that we're decreasing. To differentiate this, we're going to use the product rule. So we have 2x times e to the negative x cubed plus x squared times negative 3x squared e to the negative x cubed. All right, adding this up, we can factor out an e to the negative x cubed and an x, so we get x over e to the x cubed times 2x, times just 2. We've already factored out that x in the first term, so times 2 minus 3x cubed. Okay, so for x greater than 1, actually for x greater than the cube root of 2/3, but we don't really care what that is. As long as when x is greater than 1, this is decreasing. Excellent. Okay, so we've checked that it is eventually decreasing. Great. All right, so we have both worked out that we'll be able to calculate this integral, and we've checked our hypotheses for the integral test. So we are ready to rock and roll. So the integral from 1 to infinity of x squared e to the negative x cubed is equal to the limit as b goes to infinity of 1 to b x squared e to the negative x cubed, which is the limit as b goes to infinity of negative 1/3 e to the b cubed minus negative 1/3 e to the 1 cubed. Okay. As b goes to infinity, right, this looks like 13. It's supposed to be just 1 cubed, so I'm going to just write 1 here. Okay. So as b goes to infinity, b cubed gets very, very big. E to the b cubed is huge, and we're taking the reciprocal of this. So we're left with 1/3e. Okay, just the second term remains. So since the improper integral converges, the series converges. And we know that its value is going to be less than 1/3e, right? Because this was an upper bound. Great.